This is our experiment on the random motion of polystyrene beads. So the main idea of this experiment is to show that the motion of the polystyrene beads that are caused by collisions with the water molecules is random. So we know that when a particle is in random motion, it has an equal probability of moving in any direction. For this experiment, we did have one change in the setup since we failed to visualize any beads in the first slide that we were prepared. So we then cleaned up the slide with the Kim wipe and prepared another. Once we were able to now see some beads, the setup was complete. We then used AmScope to get a clear picture at 20 times magnification. We then made sure that there's no disruptions to the solution and allowed it to settle for a little bit, and letting it settle helped us to eliminate any flow of solution that could have occurred during setup or just by simply knocking into the table. Once the solution settled, we then started recording a video for data collection, and then we input that video into Tracker. We then used Tracker to track the position versus time of 5 beads for 100 frames each. And the variables we looked at were position in micrometers versus time in seconds. And we used that to find velocity versus time in the X and Y, and also average velocity in X and Y coordinate. So we chose to measure position versus time to find the average velocity, and which was then used in determining the random motion of the beads, since we know that the average velocity for molecules in random motion should be 0 or close to it. And a representation of data that would agree with our hypothesis would be a velocity time graph that's fluctuating, but is essentially centered around zero or a value close to 0. And this is what we were able to see in our graphs for each of the beads.
So the equations used include the average velocity for the X and Y direction, which equals to the sum of all velocities divided by the number of samples. As for our models, here we have the position magnitude of each of the 5 beads tracked. This slide shows the velocity versus time graphs in the X coordinate, and this slide, we see the velocity in the Y coordinate. Because we wanted to determine the distribution of velocities of the 5 beads we tracked, these histograms show how the velocities are in between the intervals of -0.119 and 0.561, which are close to 0.
From this data, we averaged each velocity in the X and Y coordinates and received these for beads A through E. And also at the bottom of the slide, you can see the average of all of the beads together in both the X and Y coordinate. In summary, the data that we collected does support the physical model presented at the beginning of the lab that random motion is achieved by beads colliding with water molecules, because we proved that in each case, the average velocity of most of the 5 beads tracked ended up being very close to 0 micrometers per second. This means that the beads had an equal chance of going in any direction, because each velocity that the bead had in any given time could be opposed and sent back. This type of vibrational motion that can be seen is Brownian motion, where beads stay in one place and move back and forth, but are not completely moved to a new area. However, some beads had velocities that exceeded the expected 0 micrometers per second threshold, or was under it. And that can be explained by the water flow as the cover slide was placed on our sample of water on the slide, as well as human error in tracking with Tracker on the computer program, since 100 frames had to be clicked individually. Even so, the average of all 5 beads was very close to 0, as in the X coordinate, it was 0.482 micrometers per second, and the Y direction, -0.761, showing that the beads in general had an average velocity around 0 micrometers per second, which is what we expected as the beads were moving randomly in our experiment.